The topic of this presentation is LibSearch, Similarity EI hybrid search for spectra sent from the chromatogram window. It includes both a video and a handout, and there will be a good bit of information in the handout that is not present in the video, so check out the handout also. On my website, there is the full course on the NIST 26 with newly integrated deconvolution and library searching for both EI GCMS and LC-MS-MS. There's lots of previous information on LibSearch and other NIST software on my website. And you can see all the resources on the right side here. We have videos and we have handouts and we have also other webinar resources. And you can access this to learn about the other many functions that are found in LibSearch and other programs that are not found in the brief presentation that I will give on the hybrid search today at this link here. The NIST EI hybrid search expands the power of traditional EI library matching by enabling detection of structurally related compounds through mass-shifted fragment alignment. This transforms the library from a static reference into a dynamic tool for identifying unknowns, analogs, and emerging compounds not explicitly represented in the database. Hybrid searching integrates exact and mass-shifted peak matching into a single scoring process, allowing both direct spectral agreement and systematic mass differences to contribute to the identification. While NIST EI hybrid search does not require molecular ion, its effectiveness is significantly enhanced when the molecular weight of the unknown is known or constrained. In such cases, the mass difference delta M, or delta mass, between unknown and library spectra can be interpreted directly, reducing false positives and enabling more confident structural insights. There's more detailed information on the novel NIST hybrid search for unknown identifications on my website at the following link. And as you see on the right, we have an Excel delta mass table that lists common delta masses associated with groups that can be used in unknown identifications using hybrid search, but also have videos and some associated handouts and additional supporting software courses. This page and the next page in the PowerPoint talk about the settings that need to be initiated within the LibSearch window before you do the hybrid search. But instead of showing them through the slides, I think I'll go to the software itself. If you come up to the top where it says Library Search Options, we'll come over to the Similarity search and click on that radio button, pick EI Hybrid, and pick in Spectrum and Full Spectrum Search. If you know what the molecular weight of the unknown is and you don't think that the software has selected it correctly when it did it automatically, then you can change this to whatever you want. Maybe you know the chemical ionization, maybe you understand the fragmentation better, but usually I'd leave it selected initially to do the search. The libraries we'll use are the same MainLib and RepLib. So that's pretty much the settings with this in this menu. You do the default and automation on. So now we need to go down to the bottom and make sure we have the right properties set. We want the library searched would be a good thing, the match from the hybrid score, the delta mass, the deform, the PCT relative form. Databases tells how many databases something's found in. The more databases, the more likely it could be the unknown identification, and OMatch, which we'll talk about later. And usually, if you had to set those up, go to right click, go to properties, and you can go over here and just pick those that you need. Now the setup is complete. Now we'll go process our unknown. We'll go to the chromatogram. I've actually already processed it within the chromatogram. So if you click on the green button, you can see it's not a bad fit for it, a score of 810. But if you look up the butterfly plot head to tail here, you'll see it looks like it weighs molecular weight 152, while this unknown has a molecular weight of 172. But it might have some of the parts of the molecule in it. But let's send it to the hybrid search to see if we can identify it. You right click on it and say library search. And I already had hybrids set up. And you'll see at the bottom, I did a hybrid search, the type of search EI hybrid, and it determined automatically by itself that it had a molecular weight of 152, which if I look up here, looks reasonable. So let's go back to the PowerPoint now and look at what's new. New in the NIST 26 is deform and PCT relative form. Delta mass was in the previous versions. So what's the delta mass? It's the difference in the mass of the query compound and the library compound. So that was the delta mass, which was there before. The D form highlights the mass differences corresponding to plausible structural modifications guiding interpretation. And the PCT ref form percent is the probability that a D form is correct based on the statistics of occurrences of each D form relative to the most common, CH2, which is assigned 100%, for high scoring hits greater than 900. The higher, the most likely correct. So the higher this value, values like 0.01 are so rare, they are very likely accidental and wrong, for example. So again, if you want to find out more additional about information about the hybrid search, go to the link 1 and link 2 below. So just looking at the results once again, if you didn't get this molecular weight 152, if you thought it was something different, remember you can always go up to the settings here, unclick this, and put in your value. But most of the time it does a pretty good job, so I just start within Spectrum and let it determine the molecular weight for me. We'll look at the results down here. We had the delta mass. We had several delta masses for 18. If you look at that, that's a hydrogen minus what plus a fluorine on it, difference between the top and the bottom. So it needs to add a fluorine to get up to molecular weight 152. But there's always other information like a 16 difference here and a 14 that even has a PCT relative form of 100. So we'll look at some more of those in a separate slide here in a second. Let's go back to the PowerPoint. This is the proposed structure that's consistent with 3 hits. So the first one we talked about is lost hydrogen and put a fluorine to get the difference of 18, and that's an 8.8% relative form, so still pretty high. If you go down to the next one, when you do the hybrid search, you'll often get several different hits within the next highest 5, 6, or 7 that tell you something about the molecule. So this is just another way to see it. It has a delta mass of 14, so you need to put a 14 on it somewhere. So here's where the 14 goes. Takes the place of one hydrogen, insert the methylene. And so that's reasonable. But again, same structure, again, or isomer. We can't really tell. You'd have to have some other information to know the exact isomer, maybe NMR or a standard, or maybe if you could find somewhere in the literature that had a very good RI for it, retention index maybe. And the last one, a delta mass of 16, for where you need to take out an oxygen to get there, subtract an oxygen. So you go from 168 to 152. And again, the PCT relative form's a little lower here, 1.6, but all 3 point to the same basic structure. So it's good to look through several of the proposed best hits in your hybrid search. Go back one more thing I want to show you over here. Put O match here, and that's the original match. That would be like you did an EI normal search, so you can resort by that. Here it's sorted by the hybrid match. We'll redo the O match, and that's essentially what you saw within the chromatogram results. So it's had this chlorine compounds, but it did tell you that often the original match, when you look at it, will tell you this side of the molecule. So if you put that together with the hybrid delta masses, it's very helpful in coming up with a proposed structure. So one last thing I want to do is to take this proposed structure and put it into MS Interpreter just to compare the fragmentation. So instead of drawing it from scratch, I'll just right click and say send to Default Structure Editor. It'll open whichever one that you have assigned on your computer. And I'll change the style here. Let's go to Tools, Templates, Options, Set Structure Drawing Style. We'll go to ACS Standard. All we have to do is just modify what we want to do. So we'll put another bond. Like I said, we don't really know exactly where the fluorine is, but we're almost positive it's on the ring somewhere. So I have it now. You have to select the one you want, especially if you have more than one structure. So I've selected it, say copy, puts it in the clipboard, Windows clipboard. I go back to my program and I send my unknown to MS Interpreter. So nothing's assigned so far because I don't have any structure here. So what I need to do is left click here to select the structure window and then just paste it. And it'll have our structure here for us that we put in, that we proposed in the fragmentation. So that's the molecular ion, it's the whole molecule, that's the loss of a methyl group, and that's the loss of a COCH3, and it has a 43 ion for the acetyl ion. So it looks very consistent with our proposed structure. So therefore, I hope this hybrid presentation has helped you understand the changes in the new NIST search for this year with the addition of some new parameters that help you interpret the hybrid data. And I hope you find it useful in your work to identify unknowns. Thank you so much. Good day.